So let's take a look at how to do example number 1 in this page. It says, use the limit properties to find the limit as x approaches 4 of x squared minus 3x plus 7. So notice how we read this. We start with the limit, then we describe where the x is approaching or where x is closer to, and then we describe the quantity next to the limit. And again, what we have to notice here is that we have a limit as x approaches 4, and we have what's called a polynomial next. And these things are beautiful because all you have to do really is grab the x and plug it into all the x's in the polynomial, and you're basically finished. So write down the polynomial x squared minus 3x plus 7, and notice how I did not write the x's, I left it blank, but then just replace it with the number 4 because my limit was x approaching 4. And all I have to do now is calculate the answer. So this is 16 minus 12 plus 7. So let's see, that's 4 plus 7, which is 11. And that's pretty much the end of that. So what did we just do basically? So if you want a picture or a mental image of what we just did, it's basically this. First, we graph the function y equal to x squared minus 3x plus 7. And who knows what the graph looks like? It's just some parabola basically. And next we said go to where x is equal to 4. So on the x-axis we look at where x is equal to 4. And the question is, if I'm standing real close to 4, how high is my curve on the y-axis? And we discovered that the height of the curve is roughly 11. That's the answer. So if you stand real close to 4 on this graph, your parabola is going to be real close to 11 on the y-axis. That's what this problem actually means. Now all this is great and everything, but it's not required for the problem. It just wants the limit. So as soon as you get 11, you're basically finished and you can move on to the next problem. So let's take a look at the next problem. So again, we have the limit as x approaches 0. And this time we have a square root of x squared minus 3x plus 2. So again, how do we approach the problem? We look at the limit. It's x approaching 0. Our job is to plug in the 0 into all the x's of the problem. And 99% of the time it's going to work. You're going to get some number at the end and you just move on with your life. And the couple of times where it doesn't work, you'll have to sit there and try to fix it. And I'll show you how to fix it in another video, in another example coming down in the next few minutes. So in this case, I'm plugging in the zeros everywhere where the x was because x is approaching 0, and I get 0 minus 0 plus 2, which is at the end the square root of 2. So that's my final solution. So that means that if you were to stand on the x-axis around x equal to 0, on the y-axis you will see the numbers are roughly close to square root of 2 when you are dealing with this particular problem, with this particular function. Okay, let's do it a couple more times. So example 3 says, find the limit as x approaches 1 of 2x cubed plus 3x squared minus 6. So maybe it's a good idea to pause the video right here and see if you can do this problem yourself. It's very straightforward. It's very similar to the previous two. All you got to do is grab the 1 and replace the x's with 1 in the problem. So pause the video, see if you can get the answer, and I'll give you the answer in a couple of seconds. Okay, so in this case, again, I plug in the 1. And when I plug in the 1, I get 2 times 1 cubed plus 3 times 1 cubed. Again, the x's get removed, they get taken out, and we replace them with the 1 because x is approaching 1. 1 to the power of 3 is going to be 1, and 2 times 1 is going to be 2. 1 squared is 1, times 3 is going to be 3 at the end, and then negative 6. So that's 5 minus 6, which is at the end negative 1. So again, just to kind of show you what we are doing, basically what we're trying to do here in this problem, here's kind of the idea behind this problem that we just did. If this is the xy plane and I decided to graph y equal to 2x cubed plus 3x squared minus 6, the graph would look something like this maybe. And I decide to stand next to 1 on the x-axis. If I stand next to 1 on the x-axis and look at where the curve is, I'll notice that the curve is directly across from negative 1 on the y-axis. That's what this actually means. But again, we don't have to draw the picture. All we have to do is get the negative 1, and that's basically how the problem ends. So at this point in time, we're not really interested in the graph. We're just interested in finding the limits algebraically or analytically. And we can plug in the 1 and square it and cube it and multiply by 2, multiply by 3 because of the rules that we mentioned in the first box in this section. The limit of a sum is the sum of the limits, and so on and so forth. So finally, we have a fraction. And so again, what do? Fractions are going to be the tricky ones in this chapter or in this section because there's a chance that the denominator can be equal to 0. And if the denominator is equal to 0, that's the bad situation that I'm talking about. That's where you have to kind of try to fix it. Let's see, does that happen here? If I plug in the x into all, if I plug in the 4 into all the x's, what do I get? So let's see, I have 2x squared, 5x minus 1, all divided by 3, and then x minus 2. And keep in mind that x is 4, so let's just plug it in, and I'm doing that because my x is approaching the number 4. Now again, what I'm paying attention to here in these problems when I have fractions is the denominator. Is it going to be 0? If it's going to be 0, then that's going to be a little bit bad, and we'll have to try to do more math to fix it. In this case, 3 times 4 is 12. 12 minus 2 is going to be 10, so it's not 0. So that's perfect. Seems like it's going to work out. And then 2 times 16 is going to be 32. Plus 5 times 4 is going to be 20. And then minus 1. So I believe this is 51 divided by 10 if I didn't make any calculation errors. And that's the final answer. So, it's pretty awesome. It's very simple. I hope that you're seeing that this is very, very simple. It's probably one of the easiest topics that we do in this class. So whenever you see limits, don't worry about making tables at this point or graphs. Just plug in the number. If it works, like it just did, then you're done with the problem. You move on to the next one. If it doesn't work, then you'll have to fix it, and we haven't dealt with one of those yet. It's coming down in a few minutes. Okay, so the last one in this case, in this video, is going to be the limit as x approaches 2, and then the square root of 1 plus 3x squared. Again, take a moment to pause the video here and see if you can solve this problem yourself. Okay, so I'm approaching 2. So what I have to do is plug in the 2 into all the x's. So erase all the x's. Notice how I do it all the time. I put parentheses where x was, then I fill in the number that was supposed to go there. In this case is 2. And the reason why I do that is because it helps me avoid mistakes, especially when I'm approaching a negative value. If I don't put the parentheses, sometimes I'll lose the minus or it won't square correctly or something like that. So always put parentheses. If you're not sure whether you need parentheses or not, always put parentheses. It's never going to be wrong to have extra parentheses. It will be always wrong to have less parentheses though. So this is 1 plus 3 times 4. And according to PEMDAS, I'm supposed to multiply first. So 3 times 4 is going to be 12. And so 1 plus 12 is going to be at the end square root of 13. And that's my final answer. That is basically the y value when x is super close to the number 2 on the x-axis. So if you were to graph this problem and look at the x equal to 2, you would notice that the y coordinate is going to be, roughly speaking, square root of 13.